Okay, so welcome back. In the previous video, I discussed the introduction on carburizing process. So in this video, I'll be talking about the subtypes of carburizing process. So the first thing is pack carburizing. Okay, if you can see this diagram, okay, it starts like the steel specimen is initially first heated with temperature above 727 degrees Celsius. Okay, above critical temperature. The specimen will be heated at that higher temperature. It will be held at that temperature for certain duration of time in this steel container, and at the same time it is packed with this activated charcoal all around it. Okay, that activated charcoal, again it is treated with barium carbonate so that it accelerates the carburizing process. Okay, what happens, all these things is placed in the heated container, in the steel container, and it will be sealed, and again that container also will be subjected to heat. So under so much of heated condition, what happens, the carbon content in the charcoal, if you know, charcoal is the allotropical form of carbon, right? So the carbon content of that charcoal and whatever the air is present inside the sealed steel container, both will react to produce carbon monoxide. Okay, that carbon from the carbon monoxide will diffuse onto the surface of the steel specimen. So this is how pack carburizing will take place. Name pack carburizing because it's been packed with carbon rich atmosphere. The specimen that is to be diffused, or that is to be hardened, surface hardened, it has been packed with the carbon rich atmosphere. That is why the name pack carburizing. Okay, now process is fine, but the quenching is a very big challenge because it's a steel container. You have activated charcoal, lot of heat. It's not that easy to remove the specimen outside. Okay, so one of the technique that is done is slow cooling the entire pack, and further you harden and you further temper to enhance the properties and everything that is added on. But the thing is, it's better you leave the pack, the entire pack, to just cool as it is instead of using any other method. Okay, so this is one of the reason why pack carburizing make very time consuming, because first of all, the process to happen, only you need to wait literally for 8 to 10 hours for the carburizing to take place, and then to cool by itself again for several hours. So that is one disadvantage in pack carburizing. Okay, the next thing is gas carburizing. Okay, what happens in gas carburizing is, component which is to be carburized will be heated to 900 degrees Celsius. Again, you'll bring it to austenizing temperature above the critical temperature, and it will be like heated for duration of about 3 to 4 hours in a furnace in the atmosphere of carbon rich gas as in hydrocarbon gas. What happens at that temperature, the carbon of that hydrocarbons will diffuse inside the, not exactly inside, the surface of the specimen. Okay, so that is how gas carburizing will take place. Solid carburizing is by pack of activated charcoal. Gas carburizing will take place by the hydrocarbon gas. Now the next method is liquid carburizing. Okay, now before I talk about liquid carburizing, let me talk about cyaniding. I'll tell you why I'm discussing cyaniding first before liquid carburizing. Okay, it's quite the same. What happens in cyaniding, the specimen that is to be case hardened, okay, that will be immersed in a molten bath of sodium cyanide only, where that sodium cyanide is maintained at a temperature of 800 to 870 degrees Celsius, and you are immersing that steel specimen for about 30 minutes to 3 hours, depending on how much of a depth you want. So what happens at that temperature? The carbon and nitrogen both will diffuse on the surface of the specimen. Okay, cyaniding is done basically to introduce both carbon and nitrogen on the surface. Okay, now this is cyaniding process. Okay, what happens in liquid carburizing is that little modification. It is the same procedure. You are immersing the specimen into the sodium cyanide solution, but also not just the sodium cyanide solution. You're going to add to that 40% sodium carbonate, varying amounts of sodium and barium chloride. Now with this, what happens? The carbon rich will become. The solution is not having carbon and nitrogen, just like in case of cyaniding. Okay, it has more contents of carbon than carbon nitrogen. Okay, so whatever the steel specimen you want to get carburized, you will be putting that particular specimen inside this mixture, which is maintained at around 950 degrees Celsius, and you're going to immerse it for an hour. What happens? Sodium cyanide will react with the oxygen and result in the carbon getting diffused inside. Nitrogen will not get diffused. It is, that's all, it's volatile, it goes off, it's gas. Whereas carbon, it will get diffused inside. Okay, so that is why I spoke about cyaniding first and then liquid carburizing. So by this, actually I have completed the 6th and 7th type of heat treatment process. Okay, hope I am clear with you. Don't get confused with liquid carburizing and cyaniding. It's just that the solution of the mixture, the salt solution mixture, that is all is varied. That's all. Okay, in the next video I'll be discussing on nitriding process.